morning, everyone. This is Guthrie, much soberer now, and surprisingly not hungover from last night. Anyway, the reason why I'm making this video today is you may remember my last video where I said that I wanted to compare my drunken state with my sober state, and it got me thinking, partly over the course of the night, etc., over statistical issues. I even started dreaming statistical formulas and the like. It was kind of fun. But when I woke up this morning, a flashback to a particular Mythbusters episode and an ongoing debate that I've had with Mythbusters TV series flashed back into my mind. One of the things that I have often complained about is the fact that on various different shows in the or various different episodes of Mythbusters, that there are often comparisons made, say for example between whether riding with your windows up and the air conditioner on, or windows down and the air conditioner off, are more fuel efficient. This kind of thing. And one of the things that one of my major complaints about this is the fact that there doesn't seem to be any sort of statistical analysis other than a direct percentage, i.e. no significance tests are used to get confidence intervals or rejection regions, or just even a probability value that one particular state is is statistically significantly different or better than another state. In other words, it appears that there doesn't seem to be much in the way of either one-tail or two-tail statistical tests to back up the claims of difference that the Mythbusters make, and namely, or at least not that I could tell, because they didn't present such data, and I was hoping that they would. Now, a number of my fellow skeptics who I know in person have said that Mythbusters would actually do said work. We just don't see it because of the fact that it's not interesting to the public. And my thought was, okay, I'll keep an eye on this, and actually I'll test that claim when the first opportunity comes around. It did recently in one of the latest seasons with an episode called Battle of the Sexes 2. A little bit of backdrop. In one of the myths they test in this story is the idea that one of the ideas they test in this story is that women are better multitaskers than men. Just to give you a heads up how they did this, or to set the preamble, there were 10 random women and 10 random men selected to perform a series of tasks that one would do every day in the morning. Protect a baby, make sure that a baby doesn't crawl out of the safe zone in the kitchen, make a sandwich, make your breakfast, get dressed, iron your clothes, get dressed, make the bed, all the basics, as well as being phoned to answer a series of random questions just to see how good the working is. Now, based on the evidence they got, they also had the participants in the study or in the experiment started off with a score of 100. For every penalty they took an infraction down, and then the average score was determined afterwards. Now, I have queued up the exact frame in the episode where they show all the scores for men and all the scores for women. And I'm actually going to flip to that now and walk you through the entire process that one would ideally use. Now, actually, before I do the screen share, I want to show you something in here. This is my textbook for the statistics I had to take, probability and statistics for engineering and the sciences, 8th edition. This is the latest edition, and practically every university or university transfer program that I've been in, which has had a statistics course of some description, in the pure math program, uses this book. So this is a legitimate academic textbook which talks about how to perform proper statistical tests. Now, I'm going to flip, since I don't want to be using an internet source and I can't screen share this, I'm going to flip and show you the pages manually. Now, let me see here. I am looking for the paired t-test, because that is the one that will give us a specific. Okay, that's ANOVA. It'll be chapter 9 more likely than anything else. Yes, here we go. 9.3, page 365, analysis of paired data. So when we get there, I'm actually going to show you the appropriate technique and the context as to how this works. So give me one moment here. Sorry, I understand that this is actually to provide a All right, so we are given an example of paired data, and now here's the thing. The criteria for paired data are that that again the standard deviations are still considered to be not significantly different by the traditional technique, and in both cases there is the same sample size. For example, if you take a look at this example here, example 9.9, and I hold it up really close to the camera. I know it's a little vague, but you can see that there are two separate sets of data separated by a blank space here. They have the exact same number of samples. So this would be the ideal circumstance for a paired t-test. And the correct formula for a paired t-test is the and I can show you here again. On the bottom, you have the difference. I'm sorry, this camera's not focusing properly. You have the difference, the average difference, the average of all the differences between the two data sets, minus the. Sorry, let me see if I can get it in here. There we go. Yes, minus. Sorry, a little further. No, hang on. I don't think this is the right section. What the heck just went? Oh, that's why it's not registering itself properly. One more try. There we go. So yes, the null hypothesis is that the difference between the mean of the differences is indistinguishable from chance, which in this case would happen to be no difference at all. And you minus off the average of the differences minus the chance difference over the what's that here? Sorry, the standard deviation of the differences over the square root of the number of data points in the sample. So, and the hypotheses are there is a greater than, there are three hypotheses. There's the one-tail test of greater than, the difference is less than, or the difference is not equal to. That would be the two-tail hypothesis. With that, for a rejection region, the t would have to be for greater than, the t would have to be greater than the critical t value for statistical significance. For less than, it would have to be that the t was less than the negative of the negative t in the of the critical the negative critical t. And for two-tail, well, it would either be greater than or less than, but you get the idea. It's basically you pair the two together, and you do it times alpha, and you do it to the critical t value rather than for alpha over 2. Now, in this case, let's flip to the screen share, and I will walk you through conducting this t-test. And I will actually pull up every last aspect. So this is the multitasking scores. As you can see on the top, over here, we have the scores for women with an average of 72, and the lower scores for an average for men for an average of 64. But let's actually open a Word file here. I'm going to do this manually rather than using Excel or some other program, just to make sure that I can walk you through how to do this on your own if you do not have computer software handy. So for data point 1, we have the scores are 150 for the first data set. So we have 100 minus 50 equals 50. Now 2. Minimize that. 70 and 80 respectively. So we have 70 minus 80 equals, let's see, so 70 minus 80 equals negative 10. Okay, so let's see that 70 minus 80 equals negative 10. Data point 3, 60 and 50. So 60 minus 50 equals 10. Number 4, 80 and 80. So we know that 80 minus 80 is 0. 80 minus 80 equals 0. Number 5. That will be 80 minus 90. So we have 80 minus 80 minus 90 equals negative 10. Next, number 6, we have another 80 minus 80 again. So 80 minus 80 equals 0. 7. 80 minus 50. 80 minus 50 equals 30. 8. 60 minus 60 equals 0. 9 is 50 minus 50. 50 minus 50 equals 0. And the last data point, 60 minus 50. Now, equals 10. Now, what we do from here is that we take all of these differences on the end here, and we will go below after I get rid of that, and we will add them all up to try to get a average as to what the average of the distances is for that delta D to give us an idea. So let's see, that's going to be 50, negative 10, 0. 50, negative 10, 10, 0, negative 10, 0, 30, 0, 0. I'm going to put control underline 10 just to show that we're doing an average. Okay, so that's going to be, let's see, 50 plus negative 10 is 40, plus 10 will still be 50, plus negative 10 is 40, plus 30 is 70, plus 10 is 80. So that's 80 divided by 1, 2, 3, 4, 5. So 80 divided by 10. So yeah, actually, you know what? Let's open a calculator just so this way I can show you what I'm doing to prove this point. So let's see. So that'll be, okay, so that's going to be 50 plus negative 10. No, I didn't ask for that. Sorry, minor glitch. Try that again. 50 plus 10 negative plus 0 plus... Sorry, one more time. I seem to be slipping right now. First thing in the morning and I haven't had breakfast yet. But anyway, let's try this again. 50 plus negative 10 plus 10 plus 0 plus negative 10 plus 0 plus 30 plus 0 plus 0 plus 10 equals 80. Divide by, so we'll put 80 in there, 80. Now we go divide by 10 for 10 data points equals, so now divide by 10 equals 8. Okay, so we now have a test. We now have a measured average of the differences of 8 between the 10 data points. That is our test measurement, and we will compare that to the chance difference of 0, i.e., that there is no difference between men and women as multitaskers, in order to be able to determine if there is such a difference at all. Which reminds me, before I do anything else, I'm going to go grab my I'm going to go grab my chart of statistical tables, because we're going to need this in a second. So bear with me. I had forgotten to get this. Okay. Okay. Now, where was I? Yes. So now we're going to calculate the standard deviation of these particulars. Now that we have the average, the appropriate method for determining standard deviation, let us pull that up from this book, and that'll be in the very basics at the beginning. So let's see, here we go. Where are we? This should be really early on in the book. That's relative frequency, not what I'm looking for. Might be a little further in. Well, you know what? Actually, let's look online for this. I can screen share a method for calculating the standard deviation. And this actually should be a educational lesson. How to calculate standard deviation. Standard deviation variance. Here we go. So the standard deviation to do this should be we've already shown the mean. You add up all the samples and divide by the number. So that gives you the idea. But now the variance is going to be so basically what we do is we take the wait. Hang on. I can't remember if we're using n or n minus 1 for this particular idea. Yes, the sample standard deviation. Thank you. That's the one I'm looking for. Since we're looking for the sample, not the population, this is n minus 1. And as you can see, the formula is this one here. But anyway, so yes. Basically, what this is it's going to be the sum of the data point minus the standard deviation. The sums of the standard deviation, of the data point minus the standard deviation squared over over n minus 1, which is the number of the number of data points minus 1, all under a square root. So let's actually calculate that now by returning to the data point system here. So now that we have the mean, we're now going to do the following. This is going to be, using a calculator, we will actually work out every last bit of this, and then I really got to get going because I'm running late for something. So 50 minus 8 equals 50 minus 8 to the power of 2 equals 42 to the power of 2 equals, let's see, so 42 to the power of 2, 42 to the power of 2, so 42 squared, 1764. Next, negative 10 minus 8 squared equals, to the power of 2, equals 18. Equals 18 to the power of 2. Negative 18, and I have to keep that in brackets. Negative 18 to the power of 2 equals, trying to do this very quickly here, 18 negative squared, 324. So 324. Next, 10 minus 8 to the power of 2 equals 2 to the power of 2 equals 4. That one I think everyone knows. 0 minus 8 to the power of negative 2. 0 minus 8 to the power of 2 equals, hang on, 0, okay, that's going to be negative 8 to the power of 2 equals, negative 8 to the power of 2 equals 64. Then again, negative 10, we already know where this is going. Minus 8 to the power of 2 equals negative 18. Negative 18 to the power of 2 equals 324. So again, we are following this notice correctly. So let me see, x, yeah, so that's right, so we're going there. Now we've got the negative 10, so now 0 again, so 0 minus 8 to the power of 2. Actually, you know what, we might just start copying these rather than doing pen in for the, basically for any which are obviously clear, we're just going to we're just going to copy those relevant ones and then just repaste them on the bottom to avoid having to, okay, so now 30, so 30 minus 8 to the power of 2 equals 22 to the power of 2 equals, let's see what that is. So let's see. So 22 squared equal, okay, so that's 484. 484. Then we have the 0 thing again twice. So 0, 0. And now we will copy, paste the 10 one, because that's the last one, and that's all our data points. Okay, so with all of that, we now add the pieces together for the sum, and that means, so let's see, that's going to be 1764, 324, 4, 64, 324, 64, 484, 64, 64, and 4. So, actually, let's put the control underline again to show that we're doing a sum. Okay. So now, underneath all that, we now add these together, and we get the following. Clear out the calculator. So, 1764 plus 324 plus 4 plus 64 plus 324 plus 64 plus 484 plus 64 plus 64 plus 4. That all equals 3160. So 3160. Now we divide that by 9 because 10 minus 1, divide by 10 minus 1 equals 3160. Divide by 9. And this gets us the variance. And that equals, we'll take this to, let's, to be on the safe side for t values, let's take this to 3 decimal places, so 3 significant figures. Pardon me. Okay, so 3160 divided by 9 equals, so 351.111 infinite, so we'll just drop that to the nearest 3. So that'll be 351.111. And the reason I picked 3 significant figures is you'll see why in a moment when we get to the t-tables. Now, we've taken that. We're now going to take the square root of that. So SQRT 351.111 equals, sorry, wrong bracket, equals. Let's take the square root of this number. So we'll take it to 3 sig figs and do the square root, which I know should be in here somewhere. Okay, odd. I could have sworn that it would be on the. Could have sworn it would have been on this calculator. Oh, there it is. Found it. Good. So now, actually, yeah, I'll just do it. 351.111 square root, and there we have it. 18.738 due to the roundup. So that's 18.738. Good. So we now have our standard deviation, which now allows us to do the following. This will be t equals 8 minus 0. Now, I should mention as well that because of the fact that we are looking at the idea that men are better than women, we are looking for a difference that is greater than 0. So this means that this is a one-tail test, and we are using 95% confidence interval as traditional, so that'll be alpha of 0.05. So here we go. But this is just the test statistic based on the measurement now. So 8 minus 0, divide by, I believe it was square root over m was what I showed. So, so this is going to be 18 point, so this will be 18.738 738 divide by square root of 10. So with that in mind, that will equal 8 over 18.738 divide by square root of 10 equals, now let's pull up the calculator and calculate this out. So we're now going to have 8 divide by bracket 18.738 divide by further bracket 10 square root, close first bracket and close second bracket. And now with that, we now have the following. 1.35 is our standard. 1.35 is our 1.35 is our test statistic. Now another thing. So that is our measured t. Now to go back to the book again to the paired t data at 365 to bring up what is the appropriate t that we're supposed to be looking for to compare this to. Now remember, because this is a greater than 0 difference, this measured test statistic of 1.35 has to be greater than the appropriate critical t value. Now, how do we handle that? Well, according to this, and I will attempt to show, I will attempt to flip the camera back on so that this way you guys can see the appropriate measure to handle this, which is over here. Where are we here? Oh, damn, I could have sworn we were still on screen share for all of this. Well, not to worry, I'll flip to screen share now. Sorry about that. I thought we were on screen share for all of this, but anyway, not to worry, I will do this again to show you all the relevant math. So we will pull back up the relevant math again. So once again, this is what I was talking about. These are the differences. This is adding the differences to get the average. This is the technique of the standard deviation minus the point in order to be able to squared. In order to be able to get the squares, summing the squares to get them, to get the sum, dividing by n minus 1 here, and to get the variance, and then square root of the variance to get the standard deviation. This is our measure of the average minus the chance average, or minus the null hypothesis average, divided by the standard deviation, divided by the square root of the number of data points in the sample, and we do this and measure 1.35. I will show you the latest calculation to verify that, which is about here. And again, just to illustrate my point, because we now are on screen share, this is it was this formula that is the appropriate one to use for a sample standard deviation. Now, all of this being done, now I will flip back off screen share because apparently I made a flub on that. And here we go. So now, because of the fact that this is greater than chance, we are now looking at this one here on the top. We are looking at this one on the top here for the. You can see for the average that it has to be t is greater than t alpha comma n minus 1. So n minus 1 is our degrees of freedom. Since there are 10 data points in the sample, 10 minus 1 is 9. So let's go back to the screen share so I can show. Actually, I don't even need to do that. I can actually, yeah, let's screen share that one more time so that this way I can document the degrees of freedom in here. And one more time. So this will be so degrees of freedom. Sorry, so that wasn't supposed to happen. Apologies. My computer decided to go wonky on me, and we will address this again appropriately. So DF, which is the abbreviation for degrees of freedom, equals n minus 1 equals 10 minus 1 equals 9. So now that we've done that, let's shut off the screen share and get back to the thing. So now, shutting off screen share. Okay, so we are now looking for the alpha of 9 degrees of freedom. We are now looking for the critical t value. We are now looking for the critical t value based on the. So let's see. So finding the appropriate table for the t-test. That's normal distribution, so that's z-scores. Here we go, t-distribution. So, while looking for 9 degrees of freedom at 0.05, the correct critical value to bypass, as you can see, if you follow exactly where my finger is on this, you will see that the critical value that we are looking for at 9 degrees of freedom at 0.05 is 1.833. So now knowing that that is the now knowing that that is the issue, and comparing that to our, so now that we have that, let's go back to the screen share and take care of the last of this. Let us go back to the screen share and show this. So remember, the rejection region requires that the measured test statistic be greater than the critical t statistic. So because of this fact, we have the t crit equals 1.833 for alpha of 0.05 at 9 df. Therefore, however, 1.35 is less than 1.833. Okay, I apparently dropped the 2 sig figs, but the point is that again, it's still the same issue. I made a flub in putting my number of significant figures in. However, and that's but the thing is that all the t-scores have 3 significant figures after them. So actually, you know what? Let's recalculate that last standard deviation. Actually, it doesn't really matter because according to the calculator, the standard the t-score is 1.350. So that is indistinguishable. But yes, let us toss in that last one. So now that we've corrected, 1.350 is less than 1.833. In other words, there is insufficient evidence to reject the null hypothesis. That there is no difference in ability between men and women at multitasking. There is insignificant evidence in support of the claim that women are better multitaskers than men. So what can we conclude from this? And I'm going to save this document now. I'll save this as Microsoft Word. Just so this way it's on my computer and you guys know that I have this here. Mythbusters multitasker claim. Just as a reference for later. So what can we learn from all of this? Yes, keep current format. But anyway, so what can we learn from all of this? Assuming that these techniques are right and what have you. And damn it, I think I may have. Okay, one more time. I'm gonna have to go back to screen share because I forgot to put it in. Sorry, flub. I'm gonna have to put this back in and reopen the document again. And my computer is being mildly annoying, so we're gonna do this one more time. So as we do this, let me reopen the document just to illustrate where we just were. Okay, so where were we? Should be the top most recent. Okay, so again, let's go through this again. So again, from the calculator, so again, yes, so again, as I've shown you, this is all the stuff regarding that, and we calculated out 1.350 for the t. For degrees of freedom, we've shown you that it's n minus 1 equals 9. T crit is 1.833, and 1.350 is less than 1.833. So there is insufficient evidence to reject the null hypothesis that there is no difference in ability between men and women at multitasking, and there's insignificant evidence in support of the claim that that women are better multitaskers than men. Based on this existing data, and I will show you again that it's 1.350 here. So now that we've done the screen share for that, and I have saved that data, I can close that off and shut off the screen share. What I'm trying to get at with all of this is that, So the question now remains. I believe that the claim that other people have argued with me, what I was getting back to, that Mythbusters uses statistical tests. Well, we do not have a. But however, I would like to show you via screen share how, despite the fact that this insignificant evidence, i.e., that there is insufficient evidence to support the claim that women are better multitaskers than men, let me show you from the clip how Mythbusters handled this issue. Let's tweak it back by just a tad to right about there. No, sorry, it's a little further back. It's got to go a little further back. But yeah, let's.
It saves the baby.
But most are one thing at a time kind of guys.
Hello?
So a squared plus b squared equals c squared.
Jobs that can be tackled simultaneously become a series of time-consuming interruptions.
What is 2 plus 2 times 3?
And with points deducted for incomplete tasks, and for each time Buster escapes his safe zone,
That's an infraction. Do you have kids? No, I don't. Thank God.
the poor scores are racking up. And with Buster packed off for school one last time, Tori is ready and waiting with the crunch numbers. Drum roll, please.
So the results are in. The women came away with an average of 72 points, while the men came away with an average of 64 points. So it looks like this myth is confirmed.
Ooh, so women can multitask better than men. Confirmed.
Totally confirmed. All right, confirmed.
The numbers don't lie. The average accurately reflects the girls' multitasking mastery, meaning this myth, just like Baby Buster, has been put to bed. Next on.
The key point with all of this, however, is the fact that with the appropriate statistical techniques, as I've just shown you, there is not significant evidence that women are better multitaskers than men. Now, I'm not saying that that myth is true or not, but what I am saying is the fact that from demonstrated statistical techniques, the Mythbusters effectively confirmed a myth using a statistical technique that was not appropriate. Effectively, from the data they had, they could not infer appropriately that there was any significant difference, i.e. that, statistically speaking, that women were better than men as multitaskers. Now, this doesn't confirm my point that, this doesn't actually confirm my claim that, Mythbusters don't use appropriate statistical techniques on all of their measurements, only this one. However, I do think that this does act as a contrary data point to Mythbusters using appropriate statistical techniques at every claim they make, and therefore I do believe that this at least exposes a line of further inquiry. So for those of you who watch Mythbusters regularly, I would like your thoughts in the comments below. Does Mythbusters do decent science in the name of trying to promote, in the attempt at trying to make decent television? Do the Mythbusters do good science in general? I'd like people to discuss this. Please cite specific examples as much as possible, and and I would like some ongoing analysis. I would also like some peer review of my statistical methods, the techniques I showed you, what have you, whether or not the paired t-test was the appropriate. If there's anyone with a better statistics background than I am, please tell me whether or not, even though the sample sizes were exactly the same between the men and the women, whether a two-sample t-test would have been more appropriate to a standard paired t-test. Other things of that sort. So again, if there are, if anyone would like to toss me another, so yes, please again, please peer review my results. Please peer review my results, as well as also further discussion on this and other on this issue in a much more general sense. With that in mind, I have to leave because I am running late for an appointment, but I will catch you all at a later date. Signing off. Have a great time.